In this lesson, we will be talking about arithmetic sequences and series. An arithmetic sequence is a set of numbers that is divided by a common difference. So let's take an example of an arithmetic sequence. So let's take one of only odd numbers. So 1, 3, 5, 7, 9, 11, all the way to the nth term, which is represented by a subscript n. So the first term, or a1, is in this case 1. It's usually displayed to you, so it's very easy to identify. Now the common difference is found by subtracting the second term from the first term, or any consecutive term, such as third term, second term, fourth term from the third term, etc. So here it will be 3 minus 1, which would be 2. So the common difference is 2. Then the nth term is calculated using a formula. Now the formula is a1 plus n minus 1 multiplied by the common difference. So in a question, they will ask you what is the 18th term of the sequence. Here n will be 18, and given that your a1 and d are given to you, you can use this formula to find the 18th term. So the 18th term in this case would be 1 plus 18 minus 1 multiplied by the common difference of 2. This would be 1 plus 17 multiplied by 2, which is 1 plus 34, which is 35. So the 18th term in this case is 35. Now, let's take another example so that we can reinforce this idea. I'm going to write the formula up top. For example, let's take a sequence of only even numbers, but with a difference of 4. Here the question asks, what is the 30th term of this sequence? So, firstly, let us write out our given information. A1, the first term, is 2. D, or the common difference, is 6 minus 2, which is 4. And the nth term is what we need to find out. So using the formula, 2 plus n, which is 30 in this case, as given here, minus 1 multiplied by a common difference of 4. This will be 2 plus 29 into 4, which will be equal to, let's pull out our calculators to find the correct answer, 2 plus 116, which is 118. So the 30th term of this sequence will be 118. Now let's move on to arithmetic series. What is an arithmetic series? Arithmetic series is basically the sum of all the terms in arithmetic sequence. For example, if we're given an arithmetic sequence of, let's say, 1 to 5 to 9 to 13 all the way to the nth term. The series of this sequence would be 1 plus 5 plus 9 plus 13 all the way to the nth term. So when we're writing this out, there is a set formula given for the sum of nth terms is n over 2, n which is the nth term, so that the n value of the nth term multiplied by a1 which is the first term plus the nth term. Now what happens if you're not given the nth term, which can happen in many cases? Then we will use this formula that we just looked at just to replace this entire thing with the general information consisted in the formula. So this will be n over 2 multiplied by a1 plus a1 plus n minus 1 d, or n over 2 2a1 plus n minus 1 d. Let's do a couple of problems. So in this case, let's take the same sequence and find the sum of the first 25 terms. So s of 25 will be equal to n, which is 25, over 2 multiplied by a1, which in this case is 1, plus a the nth term. But in this case, we will replace it with the 25th term given in the formula. This will be 1 plus 25 minus 1 multiplied by d, which is given by 5 minus 1, which is 4. So in this case, 25 over 2 multiplied by 2 plus 24 into 4, which is 96. This will give 25 over 2 multiplied by 98, which is 1225. We can prove this by actually adding all of the terms in our calculator, but it will definitely give 1225. Let's do another question, and this time we can try and prove it by having a smaller n value, so we can actually calculate the sum. So let's say the sequence is 1, let's do 1, 2, 3, 4, 5, and so on. So the a1, or the first term, is 1. The d is 2 minus 1, which is 1. And n will be given in the question. So what is Sn? Let's say the n is 7. So n here will be 7. So that means S of 7 is what we need to find out. So S of 7 is given as 1 plus an multiplied by n by 2. So 1 plus 7 minus 1, 1, which is the d, multiplied by 7 over 2. This will be 2 plus 6 multiplied by 7 over 2, which will give 4 into 7, which is 28. Now, to prove this, let us do a literal sum directly. So we will calculate 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. 3, 3 plus 3, 6, 6 plus 4, 10, 10 plus 5, 15, 15 plus 6, 21, and 21 plus 7 is 28. 28 is the correct answer, which is the correct answer we used with the formula. Now let us look at some hard questions. The first question we will look at says that the fifth term of a sequence is 22 and the 15th term is 62. Now what will be the 100th term of this sequence? So we have two pieces of information given to us, the fifth term and the 15th term. So first, our first plan of action would be to write out the fifth and the 15th term in the way that it's represented using the first term and n minus 1 and d, this formula that's given right here. So a of 5 is a1 plus 5 minus 1 multiplied by d, and a of 15 is a1 plus 15 minus 1 d. Now let's subtract a5 from a15. So a15 minus a5 will give a1 plus 4d minus a1 plus 14d. The first terms will cancel out, and you'll be left with, oh wait, I did it the other way around. a1 plus 14d minus a1 plus 4d. Yet again, the first terms will cancel out, and you'll be left with 14d minus 4d. You can put in the real values of the 15th term and the 5th term as given in the question. So 62 minus 22. So 10, so this is 40 is equal to 10d. Therefore, d is equal to 4. Now we have d is given is equal to 4, so we'll write it up here and we'll restart this. Now that we know the common difference, we can write out the fifth term, which is equal to a1 plus 5 minus 1 multiplied by the common difference of 4. We can put in the real value of a5, so 22 is equal to a1 plus 4 into 4. So a1 is 22 minus 16. So a1 is actually 6. So we have found a1 and we have found the common difference. Now to find the n term, which is 100. Simply input all the values into the formula. So a100 is equal to 6 plus 100 minus 1 multiplied by 4. This gives 6 plus 99 multiplied by 4. So 99 multiplied by 4, if we put it in the calculator, gives 396. So 6 plus 396 gives a sum of 402, which is the 100th term. So the 100th term of this sequence is 402. That is how you do a question when you're not given the common difference or the first term, but just two random terms from the sequence. Let's move on to the next question. The next question states that the sixth term of a sequence is 52, the common difference is 10. So what is the 15th term? Now we have the sixth term, so let's write out a6 is equal to a1 plus 6 minus 1 multiplied by the common difference of 10. So 52 is equal to a1 plus 50. So a1 is actually 2. Now that we have a1 and we have the common difference d, we can find the 15th term pretty easily. So a15 is equal to, let's write out a1, which is 2, just so that we don't forget. A15 is equal to a1 plus 15 minus 1 divided by d. So 2 plus 14 multiplied by 10. So this is 2 plus 140, which is 142. So the 15th term of this sequence is 142.